Hello, welcome back to our discussion of chemical bonds. Here's where we left off after video 1, talking about classifying bonds based on the electronegativity difference between atoms. In class, we did the activity where we looked at different combinations that could make possible compounds. And you will notice that when a metal bonds to a nonmetal, the bond is often ionic. Again, it's not always ionic, but often ionic. And when a nonmetal bonds with a nonmetal, the bond is covalent. Whether it is nonpolar covalent or polar covalent depends on the types of nonmetals involved. Nonmetals that are often involved in forming polar covalent bonds include oxygen, nitrogen, and sulfur. All right, so let's talk about compounds. Again, elements form compounds because they don't have an octet of valence electrons by themselves. So by sharing or giving away electrons or adding electrons, they can form an octet and make a compound. So compounds are classified by the types of bonds that are involved in the elements that are bonded together to make the compound. For instance, sodium chloride. It's a bond between sodium and chloride ions. This is an ionic compound because sodium loses its one valence electron easily, chlorine picks it up, and the two oppositely charged ions attract to one another, forming an ionic bond and therefore an ionic compound. Nitrogen triiodide, or Ni3, is a covalent compound because when nitrogen bonds with iodine, it makes a polar covalent bond between them. Again, nitrogen hogs the electron slightly, but they are still shared between the two atoms. There are many compounds out there. So some compounds will contain both ionic and covalent bonds. For example, NH4NO3, known as ammonium nitrate. This is an ionic compound because the bond between what is known as NH4 positive, which is a positive polyatomic ion called ammonium ion, and NO3 negative, which is a negative polyatomic ion known as nitrate, those obviously are opposite ions and will bond together ionically. However, you can see these charged ions, these groups of atoms that have a charge, have to be held together themselves somehow. So in the case of nitrogen bonded to hydrogen in the ammonium ion, those again are polar covalent bonds. Nitrogen bonded to the oxygens in the negative nitrate ion are nonpolar covalent bonds. So overall, the compound has covalent bonds holding the parts of the polyatomic ions together, but then an ionic bond holding the compound itself together. Here's a list of some very common polyatomic ions. Again, notice they are all groups of atoms, so they must be bonded together. Again, typically covalently bonded together. Then that group has a charge. The reason it has a charge is because the atoms are bonded in a way that they tend to have extra electrons than they normally would. Hence, many polyatomic ions are negative. Notice ammonium, NH4 positive, is obviously a positive ion, meaning it has one less electron than is normally present in that group of atoms. So again, although there are covalent bonds holding these ions together, they are not compounds yet. Compounds are always neutral. Okay? These are all charged ions. These ions must ionically bond with something else in order to form a compound. When we do have ionic compounds, okay, the properties they will tend to have in common. They will be solid at room temperature. Ionic compounds have very high melting points. Ionic compounds are all called salts. Okay, so again, sodium chloride is table salt, but it is one of thousands of salts. Okay, pictured are many different salts, okay, one of which kind of looks like sodium chloride, but obviously the others do not, and even though they're colored, okay, they are definitely still salts because they are ionic compounds. Ionic compounds also tend to be soluble in water, meaning again, they will dissolve in water. And they will conduct electricity when they are dissolved, or if you get them hot enough beyond their melting point and actually get them into their molten form. But most notably, they will form solutions that conduct electricity. For covalent compounds, we see a big range of properties. They can be gases, liquids, or solids at room temperatures. Okay, this is because they have lower melting points than ionic compounds. Covalent compounds are referred to as molecules. And some of them are soluble, but only if they are polar covalent compounds. Water itself is a polar covalent compound. Again, oxygen hogs the electrons there. So only things that are also polar covalent will dissolve. Okay? Again, we just mentioned a minute ago, ionic compounds will dissolve, okay, because they have positive and negative ions which the water surrounds. When covalent compounds do dissolve, however, they will not conduct electricity. Okay, so for instance, sugar, we know will dissolve into water. Sugar is a polar covalent compound. A solution of sugar water will not conduct electricity, while a solution of salt water will. The difference is, to conduct electricity, you have to have positive and negative ions present to move the electric current, which is a flow of electrons through the solution. And those compounds which are both, okay, both ionic and covalent, they have the polyatomic ions in them. Again, there's covalent bonds holding the parts of the ion together, and there's ionic bonds holding the compound together. So the compound properties, okay, most closely match the ionic compound properties as well. So as before, we see they are usually solid at room temperature. Again, they are also classified as salts. They are typically soluble in water, although some of these will have insoluble types. And again, they will conduct electricity when dissolved. Okay, pictured are some common polyatomic ion salts. Okay, first nickel nitrate, and then ammonium phosphate, which is a very common fertilizer. One last note, there is a special type of covalent bond. It is known as a coordinate covalent bond. Again, here what makes it special is that in a typical covalent bond, each atom must provide one single valence electron to be shared between the atoms. But in a coordinate covalent bond, one atom supplies a paired set of electrons. The other atom or ion does not supply anything to the bond. This is a very unique type of situation. It is often how many of those polyatomic ions form their covalent bonds between the different parts and hold the parts of the polyatomic ion together. For example, in NH4 positive, which is the ammonium ion, nitrogen in the middle, again, has 3 single valence electrons, and nitrogen has a pair of valence electrons in its s orbital. Hydrogen, of course, has only 1 single valence electron. So 3 hydrogens make regular covalent bonds with the 3 single valence electrons of nitrogen. However, a hydrogen ion, a hydrogen ion is missing its electron. It still is looking, though, to fill that valence shell with 2 electrons. So the pair of electrons from nitrogen can bond to a hydrogen ion. Nitrogen supplying both electrons in the bond, and the hydrogen ion supplying, of course, nothing except the empty valence level for the electrons to go into. So again, this is known as a coordinate covalent bond. I will not expect you to be able to recognize or draw these, but I do want you to be aware that they do exist. While most covalent bonds, again, are single electrons shared between atoms, there is a special type called a coordinate covalent bond where one atom supplies both. Again, it is typically found in the formation of those polyatomic ions. And that's it. Please review these notes many times to learn about covalent and ionic bonding.